Good morning, students. Good morning, all. I welcome you all to the Telangana State Model School webinar series. Today we have math session and we are dealing with straight lines chapter. And to present this straight lines chapter, we have with us an eminent administrator, a passionate academician, and a valor, right? I should call her because in her tough schedule, in her tight schedule, she's preparing her PPTs in amazing manner and she's presenting lessons continuously from past 2 to 3 sessions. So in the previous class, Madam has discussed conditions for concurrency of straight lines and intersecting lines, and we have learned so many problems based on that. Today Madam is going to introduce and going to deal with some other interesting topics from straight lines. So I welcome you, Madam, and I hand over this session to you.
Thank you very much, madam. That was so nice of you. So good morning to all the viewers and students. This is Eswari from the Telangana Model School. So we have been dealing with the previous lessons, straight lines. Hope you have followed. Try to see the videos again and again so that this is one topic which you will need throughout your career. Because straight lines is one chapter that's going to follow you. Okay, so for today, let us see what we are going to learn. So in the previous sessions, as madam has rightly said, we have seen the slope of the line and the conditions for concurrency, etc. So let's recall all of them, whatever are majorly important. And today we are going to go ahead and check angle between two lines, length of perpendicular from a point to a line, distance between two parallel lines, and foot of the perpendicular. That's what we are going to learn today. So shall we start? Yes, here we go. So in the first lesson, you have learned about what is slope. Slope is the angle, positive angle, made with the positive x-axis in the positive direction, whose tan value gives us the slope m. I hope all of you remember this. Now let us go ahead with the slope. And also, I hope you remember the slope of x-axis is 0 and slope of y-axis is infinity or undefined. We also have seen the different forms of straight lines or the shalkaras of the straight line. We have the standard form, ax plus by plus c equal to 0, slope intercept form, point slope form, 2-point form, symmetric form, and also the normal form. These are all the different types of forms which you will be using according to the data that is given to find the equations of straight lines and to understand a straight line in all different modes. Now here, today, and we are going to continue with the half planes. Yesterday we have seen, day before yesterday, we have seen about the half plane. A line divides a particular plane into three parts. That is, the points on the line, which will have L equal to 0. The points on one side of the line, where L will be greater than 0. And the set of points on either side of the line for which L will be less than 0. Day before yesterday, I mean, in the previous video, we have seen the elaborate explanation of this and how we get greater than 0, less than 0. And also, we have seen that if there are 2 points on either side of the line, then how to find the ratio in which the line divides the joining of the points ax1, y1 and bx2, y2. The ratio is given by minus L11 is to L22. Dear children, this is one important point that you have to note it down and remember even for your public exam also for all your competitive exams. Now, for your competitive exams, this point will help you a lot. Whenever L11 and L22 are of opposite side, always the ratio will be positive, and if the ratio is positive, the points are on either side of the straight line. That is, they are on the opposite sides. Now, if this are positive, then obviously we have the same sign, and so they will be on the same side of the straight line. Okay, so if the ratio is negative, you will have the points on same side. If the ratios are positive, you will have on opposite sides. Now, how does x-axis divide AB? Now, x-axis divides AB in the ratio minus y1 is to y2, as you can see in the diagram. And y-axis divides AB in the ratio minus x1 is to x2. So it is very simple to remember. X divides in the ratio of y coordinates and y divides in the ratio of x coordinates. This is what you have to remember here. Now the next point for today, let's go ahead with today's class. And today we are going to learn about the angle between two straight lines. Now, as you can see in the diagram, there is a line which is making an angle theta 1 with x-axis. And there's another line which is making an angle theta 2 with x-axis. Now, the angle between these two lines, what does it become? It is this particular angle which is between both the lines, which is theta 1 minus theta 2. So that is what we call as angle between two lines. Now the angle between two lines here is theta 1 minus theta 2. That we are going to represent it as theta. So that is how we find the angle between two lines. So if theta is the angle between the two lines, then how can we find it if the standard form is given? So the angle between the straight lines, L1, A1x plus B1y plus C1 equal to 0, and L2, A2x plus B2y plus C2 equal to 0 is given by the formula cos theta is equal to modulus of A1, A2 plus B1, B2 by root of A1 square plus B1 square into A2 square plus B2 square. Now here we need to remember this formula. It is just the product of coefficients of x plus product of coefficients of y by a1 square plus b1 square, which are the coefficients of x and y of the first line, a2 square plus b2 square, which are the coefficients of x and y of the second line. So dear children, please remember this formula throughout this session. Cos theta is a1 a2 plus b1 b2 by root of a1 square plus b1 square into a2 square plus b2 square. Now we are not going to deal with the proof of this because it is a basic understood thing. And now how are we going to apply this for perpendicular lines and parallel lines? First, let us see if there are two lines which are perpendicular to each other, then what are the conditions? A necessary and sufficient condition for the lines L1 and L2 with equations A1x plus B1y plus C1 equal to 0 and A2x plus B2y plus C2 equal to 0 to be perpendicular is that A1 A2 plus B1 B2 is equal to 0, because here theta is going to be 90 degrees, and you can see in the previous slide the formula. If cos 90 degrees, if theta is 90 degrees, we all know that cos 90 degrees is 0. And so the denominator will become 0 here, and we will only have the numerator. So from this formula, if theta is 90 degrees, we will have only this numerator, which you can see as the condition in the next slide. So here it's a perpendicular. The condition is A1, A2 plus B1, B2 is equal to 0. Also, you can simply write the equation of the straight line directly from the standard form using this condition. What is the change that is going to happen with the standard form? The ax plus by plus c equal to 0 will take the form bx minus ay is equal to k for the perpendicular line. Please make a note, children. Here we are going to simply exchange the coefficients of x and y and change the sign of the second term. That is the change here. A is going to become B and B is going to become A, and the sign of the second term is going to be negative. So the ax plus by plus c equal to 0 will take the form bx minus ay is equal to k. This will help you to calculate faster the equation of a straight line which is perpendicular to the given straight line in the standard form. Now what happens? What will happen to parallel lines? Just see. The parallel lines will have a condition A1, B2 is equal to A2, B1. We have seen this condition in the previous lesson also, where the coefficients, the ratios of the coefficients will be equal. A1 by A2 equal to B1 by B2. From there only we have derived this condition. A1, B2 is equal to A2, B1. And now what will happen to the standard form? If two lines are parallel, it's very easy to remember that the standard form will only change by its constant. You can see here, this ax plus by plus c equal to 0 will simply take the form ax plus by equal to k. So my dear children, please remember, if two lines are parallel, then the equations will only differ by their constants. If two lines are perpendicular, then they only differ by their coefficients of x and y. The coefficients of x and y will differ and the constant will change. Okay, so this is how we can write the equations of lines perpendicular to the standard form and parallel to the standard form. Now, what is the equation of the line if it is containing 3 points? The straight line containing the points ax1, y1 and bx2, y2 is this x minus x1 into y1 minus y2 is equal to y minus y1 into x1 minus x2. Hope you remember this is 2-point form of a straight line. Now, similarly, the straight line containing the points x3, y3 and x4, y4, using the same 2-point form, we get x minus x3 into y3 minus y4 is equal to y minus y3 into x3 minus x4. Therefore, from the above note, the lines A, B and CD are perpendicular if and only if x1 minus x2 into x3 minus x4 plus y1 minus y2 into y3 minus y4 is equal to 0. Here you can clearly observe that it is only the difference of x coordinates, product of the difference of x coordinates plus product of difference of y coordinates. If that is equal to 0, you can simply say that those two lines are perpendicular. Now to say whether they are parallel or not, it is very simple. The coefficients of x and y will be same. Only change will be its constant. I hope you got it. Yeah. Now let's move on to the another form to find the equation and the angle between two straight lines. Now here we can use tan formula also. Here, if L1, L2 are non-vertical straight lines with slopes M1 and M2 respectively, then the angle between them is tan inverse M1 minus M2 by 1 plus M1, M2. There we have seen cos theta is equal to A1, A2 plus B1, B2 by root of A1 square plus B1 square into root of A2 square plus B2 square, where you know the equations in the standard form. Now, if you know the slopes of the lines that are M1 and M2, you can use this particular formula. Tan theta is equal to M1 minus M2 by 1 plus M1, M2. Now, what happens if M1 plus M2 is minus 1? This denominator will become 0. If the denominator is 0, you know the condition is infinity. For what angle we will be getting infinity? It is theta equal to 90 degrees. So this formula will give M1, M2 is equal to minus 1 whenever the angle is 90. And for all other angles, tan theta is M1 minus M2 by 1 plus M1, M2. Now let us see one example here. Let us try to find the angle between the lines 2x plus y plus 4 equal to 0 and y minus 3x is equal to 7. Now here, how do you go? Just now we have learned that the angle between the given lines is given by cos theta is equal to modulus of a1 a2 plus b1 b2 by root of a1 square plus b1 square into a2 square plus b2 square. Is it not? Now let us try to identify what are a1, a2, b1, b2 from the lines. So the given lines are 2x plus y plus 4 equal to 0 and y minus 3x is equal to 7. Is it not? Now from this, we understand that a1 is 2, a2 minus 3, b1 1 and b2 1. Now let us substitute these values in this formula of cos theta. Now cos theta is a1 a2 plus b1 b2 by root of a1 square plus b1 square into a2 square plus b2 square. So in this, if I substitute the values of a1 a2 b1 b2, I will get cos theta is equal to 2 into minus 3 plus 1 into 1 by root of 2 square plus 1 square into root of minus 3 square plus 1 square. Now on simplifying that, you will get minus 6 plus 1 by root of 4 plus 1 into 9 plus 1. As you know, minus 6 plus 1 will give us minus 5 actually. And because of the modulus, that minus 5 will become plus 5. And in the denominator, we have root of 5 into 10. Now, as you know, 5 into 10 is 50. 50 is nothing but 5 root 2 because you can write it as 25 into 2. So 25 into 2 will become 5 root 2. Now the numerator and denominator, the 5 gets cancelled and you have cos theta is equal to 1 by 2. And you know what angle you will be getting 1 by root 2. I hope you remember from your 10th class that cos will have an angle 1 by root 2 per 45 degrees. So if theta is pi by 4, then cos theta is 1 by root 2. Or cos theta is 1 by root 2, then theta is going to be pi by 4. So this is how we find the angle between two straight lines if they are given in the standard form. Now we also have another example which will tell you, even without using cos theta and tan theta, simply looking at the equations, we can easily tell what is the angle between the lines. Now here, what are the equations given? We are given root 3x plus y plus 1 equal to 0 and x plus 1 is equal to 0. Now how do we go with the solution? Now just by looking into the straight line, root 3x plus y plus 1 equal to 0, we can guess that slope is minus 3 root 3. How? You can either say from the standard form ax plus by plus c equal to 0, the slope is minus a by b, which is minus root 3 by 1 equal to minus root 3. Or you can also change this to slope intercept form, that is y equal to mx plus c. There also you can see that m is minus root 3. Now, if m is minus root 3, now what is the angle that it is making with x-axis? If m is minus root 3, obviously we can say that it is nothing but the angle 60 degrees which it makes with the positive x-axis. Now, if it is making 60 degrees with the x-axis, as you know, the angle between x and y is only 90. If it makes 60 with x-axis, obviously now we understand that it makes angles 30 with y-axis. Is it not? Now, how is the other line? The other line is simply a vertical line because it is in the form of x plus 1. Hope you remember in lesson 1, we have dealt with equations of line which are parallel to x-axis and y-axis. Now, whenever there is a line of the form x is equal to plus or minus k, I hope you remember that it is a line parallel to y-axis. So, it is a vertical line which is x plus 1 equal to 0. So, vertical line means it is parallel to y-axis. So, if y-axis is making 30 degrees, obviously this equation also makes 30 degrees. So, the angle between these two lines is simply 30 degrees. Like this, you can simply apply the logic and guess what is the angle between the two lines by just looking into the forms. Hope here you will understand how important to learn the different standard forms, how they'll help you to solve problems even without using the formula. So this type of techniques you can use in your MSET or IIT JEE, where you can solve problems very easily in no time. Now, let us move on to the next topic, which is length of perpendicular from a point to a line. Dear children, this video is going to be very costly for you because there are a lot of topics in this which are quite important, not only in the point of public examination, but also important in view of your other competitive exams. So here is one important topic here, which is length of perpendicular from a point to a line. Now, what is the length of the perpendicular from a point P of x naught, y naught to the straight line ax plus by plus c? And the formula is modulus of ax naught plus by naught plus c by root of a square plus b square. It is simple substitution of the point x naught, y naught in the standard form in the place of x and y. That is the numerator. We observe the numerator. The numerator is nothing but substitution of this point x naught, y naught in the place of x and y. Okay. Now, how do we go with the proof? The proof is also something important which you have to learn for your IP. See, there is a line like this, which is making the which is intersecting the coordinate axis. Now, what is that we require? We require the length of the perpendicular from a point of x naught, y naught to the straight line AB here. Okay. Now, this length of perpendicular, let me translate and take it from the point to the origin. So, hope you remember Principal Sridev Madam's class where she was interestingly telling you how you can transform the equations of straight lines by shifting the origin. Do you remember the shifting origin which Madam has told? Yes. Here we go with the application. You can here see how I'm going to apply the translation of axis where the origin is shifted from 0, 0 to P of x naught to y naught. That is a concept I'm going to use here to prove the length of the perpendicular formula. So here the equation of the straight line, let AB be the straight line ax plus by plus c equal to 0. If the axis of the coordinates are translated to the new origin P of x naught to y naught, then the coordinates will become what? The old coordinates are small x comma y, the new coordinates are capital X comma y. Where what is the relation between these two things? Small x is capital X plus x naught and small y is capital Y plus y naught. This is how we shift the origin and get a new origin. So from 0, 0, we have shifted and so it will also get transformed. Initially it was ax plus by plus c equal to 0. Now it has become a into x plus x naught plus b into y plus y naught plus c equal to 0. Let us simplify this on multiplying ax plus ax naught plus by naught plus c equal to 0. Now on separating x and y, we get ax plus by plus ax naught plus by naught plus c equal to 0. Now, if you remember, the perpendicular distance of AB from origin with respect to the new axis, it is modulus C by root A square plus B square. And here in the place of modulus C, we have got AX naught plus BY naught plus C by root of A square plus B square, which becomes the perpendicular distance formula from a point X naught Y naught to the straight line AX plus BY plus C equal to 0. So I repeat once again. The perpendicular distance from the point P of x naught, y naught to the straight line x plus by plus c equal to 0 is given by modulus of x naught plus by naught plus c by root of a square plus b square, which is nothing but substitution of the point x naught to y naught in the place of x and y in the standard form. Okay. So the proof we have to go through once again. Please rewind and look into the proof and make it in your notebook, CWs, so that it will help you for your public exam. Now let us see one example where you're going to use this formula. Find the perpendicular distance from the point minus 3, comma 4 to the straight line 5x minus 12y equal to 2. So what is that I have to do? I only have to substitute the point minus 3, comma 4 in the place of x and y. And this is how we are going to substitute. Now here, as you can see, A is 5, B is minus 12, C is minus 2, and x naught, y naught are minus 3 and 4 respectively. So I'm going to substitute in the place of uh, x minus 3. So by which I'll be getting 5 into minus 3 minus 12 into 4 minus 2 by root of 5 square plus 12 square. So this is minus 15 minus 48 minus 2, which will sum up to 65. And because of the modulus, the minus is lost. And here it is a distance. Distance can never be negative, is it not? That is why we put the symbol modulus. And so we don't get any negative value. So summing up all the negative values, we get 65, which is divided by root of 5 square plus 12 square, which is 13. So 65 by 13 is giving us 5 units there. So it is actually 5 units. So the perpendicular distance is 5 units away from the given point. Now let us go into the next topic, that is distance between two parallel lines. Now how do you find the distance between two parallel lines? It is simply the perpendicular distance again. So the distance between two parallel lines, as we have discussed previously, the parallel lines will only differ by their constants. Here you can see in the hypothesis, see the lines are ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0. And these two lines, what is the difference? The difference is only the constant, nothing else, is it not? The x and y coefficients are same. The only difference is C1 here and C2 there, which means we have only the constants which differ in parallel lines. So if there are two parallel lines like this, then what is the distance between these two parallel lines? And the answer is the distance between these two parallel lines is simply the difference of the constants, which is modulus of C1 minus C2 by root of a square plus b square, which are the coefficients of x and y. Now, how do we get this? We have to look into the proof. Let P of x naught, y naught be a point on the straight line L1, which is ax plus by plus c1 equal to 0. And we have another line L2, which is ax plus by plus c2 equal to 0. Is it not? Now let me substitute this point x naught, y naught, which is lying on L1 in the place of x and y. So because P lies on L1, it becomes ax naught plus by naught is equal to plus c1 equal to 0. Let's take this plus c1 to the right side. We will get minus c1. Now here, now the distance between the parallel lines L1, L2 will be equal to PM, where PM is the perpendicular distance of P from L2. Now here PM is what? It is again the perpendicular distance formula. Perpendicular distance formula, just now we have learned, it is nothing but ax naught plus by naught plus constant by root of a square plus b square. Now here, for here, the second line, the constant is C2. So what is PM? Modulus of ax naught plus by naught plus C2 by root of a square plus b square. Now ax naught plus by naught plus C1 minus C2 by root of a square plus b square, where ax naught plus by naught is nothing but minus C1. If you substitute that part, you will get modulus of C1 minus C2 by root of a square plus b square. So how are we going to see this geometrically? See, these are the two parallel lines, and this is the perpendicular distance between the two parallel lines. So P is lying on one line, M is lying on the other line. The distance between these two lines, the perpendicular distance between these two lines is called the distance between the parallel lines. So what is the distance between parallel lines? It is modulus of C1 minus C2 by root of a square plus b square. So this is how we have seen. Now let us move on to the most important part of today's topic, that is foot of the perpendicular. Now, what is foot of the perpendicular? Suppose I've got a line like this, and there is another line which is perpendicular to the given line. Now, wherever the line meets the other line, that is called the foot. Here you can see a star here. That star is called the foot of the perpendicular. Now here there is a point called P of x comma y on the line, and the foot of the perpendicular is given by Q of h comma k. Now I want the coordinates of Q of h comma k. Now how are we going to find that? Now there is a beautiful proof for this which we are supposed to learn and practice. So my dear students, try to learn this and try to practice this, because you will need this for your public exam and also the substitution part. Now here the theorem is like this. If Q of h comma k is the foot of the perpendicular from P of x1, y1 on the straight line x plus by plus c equal to 0, then what is the foot? The foot h comma k is given by the formula h minus x1 by a is equal to k minus y1 by b is equal to minus ax1 plus by1 plus c by a square plus b square. My dear children, this is a very, very, very important theorem, and the proof also has to be learned because it is quite repeatedly, quite commonly asked in the public examination. So please try to practice this theorem number of times until you get it perfectly. Okay. So what is the theorem? The theorem is about finding the foot of the perpendicular, which is Q of h comma k. And how do we get that h comma k? By using the formula h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square. Now, how do we go with the proof? Let us see the proof. The proof here starts with perpendicular concept. Here we know that the line PQ is perpendicular to the line L. Now, L is in the standard form. It is ax plus by plus c equal to 0. Now, just today we have learned how to write the perpendicular equation. You only have to interchange the coefficients of x and y and change the constant. Is it not? So here if I change the coefficients, I will get bx minus ay is equal to bx1 minus ay1, because x1, y1 is a point which is lying on PQ. Now since Q of h comma k is a point on PQ, it has to satisfy the equation. What do you mean by satisfying the equation? You have to replace x and y in the above equation with h comma k. So this equation will become b into h minus x1 is equal to a into k minus y1. Now just take the cross multiplication. You will get h minus x1 by a is equal to k minus y1 by b. Right? So finally, what is that we got? We got here in the previous slide, h minus x1 by a is equal to k minus y1 by b. Now let us translate the point to x1 comma y1. So in the place of h comma k, let us take h is equal to a lambda plus x1 and k is equal to b lambda plus y1 for some lambda belongs to R. Since h comma k is a point on E, we have a into a lambda plus x1 plus b into b lambda plus y1 plus c equal to 0. And on simplifying this, we will get lambda is equal to minus a1x plus b1y plus c by a square plus b square. And that is how we will get the formula h minus x1 by a is equal to k minus y1 by b is equal to minus ax1 plus by1 plus c by root of by a square plus b square. Okay, so here there's a small mistake. This is x1 actually, which is the suffix of x. So we are actually substituting the point x1, y1 here. And here also it is p y1. Okay, so that's we get the formula hx1, h minus x1 by a is equal to k minus y1 by b is equal to minus ax1 plus by1 plus c by a square plus b square. Okay, so that's how we get the formula. So let me repeat the whole proof for you once again. So you can see in the previous slide, this is how we started. So just want to stress the foot of the perpendicular theorem for you. So the foot of the perpendicular will look like this. Now the theorem says if q of h comma k is the foot of the perpendicular from x1 y1 on the straight line x plus by plus c equal to 0, then h minus x1 by a is equal to k minus y1 by b is equal to minus ax1 plus by1 plus c by a square plus b square. Also, how do we go with the proof? The proof is if PQ is perpendicular to L, then PQ will take the form Bx minus Ay is equal to Bx1 minus Ay1. Now, because h comma k is a point on this particular straight line, we have BH minus AK, BH minus AK is equal to Bx1 minus Ay1. And so, if you take the common there, we will get B into H minus X1 is equal to A into K minus Y1. Now, on cross multiplying, we'll get H minus X1 by A is equal to K minus Y1 by B. Okay. Now, here you are translating the point, and so H is A lambda plus X1 and K is B lambda plus Y1 for some lambda belonging to R. Since Q of H comma K is a point on L, it should satisfy the equation. And so A is A into A lambda plus X1 plus B into B lambda plus Y1 plus C is equal to 0. If you simplify this, actually you will get A into A will become A square lambda plus AX1 plus B into B lambda, which is B square lambda plus BY1 plus C. Now you take all the terms of lambda to one side, all the terms of other terms other than lambda to the other side. And if you separate them, you will get the value of lambda, which is minus AX1 plus BY1 plus C by A square plus B square. Now this lambda will be equal to the previous ratio. And so equating all the three ratios, we have H minus X1 by A is equal to K minus Y1 by B is equal to minus AX1 plus BY1 plus C by A square plus B square. Now let's see one example on the foot of the perpendicular. Find the foot of the perpendicular from minus 1 comma 3 on the straight line 5x minus y minus 18 equal to 0. So here h comma k is the foot of the perpendicular from minus 1 comma 3 on the line 5x minus y minus 18 equal to 0. Right? So here a here is 5, b equal to minus 1, c equal to minus 18, and in the place of x naught, y naught, we have to substitute minus 1 comma 3. So here using the formula h minus k, h minus x, that is h minus of minus 1 by a will become h minus of minus 1 by 5 is equal to k minus 3 by minus 1. That is equal to minus ax1 plus by1 plus c. That is simple substitution of this point in the straight line. 5 into minus 1 is minus 5 minus 3 minus 18 by a square plus b square, which is 25 plus 12. So here, what does this become? The entire thing will become 1. And so h plus 1 by 1 is equal to 5. And k minus 3 is equal to minus 1, from which we can easily derive that h is equal to 5 minus 1, 4, and k is equal to minus 1 plus 3, which is 2. So this is we can use the foot of the perpendicular formula. So let us once recapitulate the formulae that we have learned today. We have learned about uh, we have learned about the distance, the angle between two lines, which is given by cos theta is equal to a1 a2 plus b1 b2 by root of a square plus b square. We also have seen that tan theta is equal to m1 minus m2 by 1 plus m1 m2. Then we have seen the length of the perpendicular from a point to a line, which is modulus of ax naught plus by naught plus c by a square plus b square. Then we have moved on to finding the perpendicular distance, which is modulus of ax naught plus by naught plus c by root of a square plus b square. Then we also have seen the distance between two parallel lines, which is modulus of C1 minus C2 by root of A square plus B square. Then the most important part of today's class is the foot of the foot of the perpendicular, which is h minus x1 by A is equal to k minus y1 by B is equal to minus ax1 plus by1 plus c by a square plus b square. So these are the important formulae that we have seen for today. And we also have seen examples based on this particular concepts. So, so this is the example that we have seen to find the foot of the perpendicular. So the similar way, we also have the image of a point, which we will be seeing in our next class. Okay, children. So for today, please to revise these points. What are all the things that we have learned today? So we have learned about what the first thing is angle between two straight lines. Then we have seen about the length of the perpendicular from a point to a line. Then we have seen the distance between two parallel lines. And finally, we have derived the formula for foot of the perpendicular. My dear children, this part is going to be very important, and this is called the heart of the straight lines, where you are supposed to practice all these theorems. Unless you practice, you won't get them perfect. Hope you all know practice makes man perfect. Is it not? So please try to do the proofs number of times until you become perfect, because they're quite important, not only for your public examination, but also for all your competitive exams. Okay, so that is the total entire part for today. Though I'm left with time, I don't want to continue with more concepts because it will be dumping of too much into your brains for today. I think I can end my session here. And thank you so much for listening to me very patiently. I know it's very hard to listen pure sciences like mathematics throughout, where we go only with the concept very seriously, where we can't talk about anything else other than mathematics. So thank you very much for listening very patiently, and please review the video again and again until you get perfection. Thank you. Thank you so much. Over to Sridevi ma'am. Madam, are you there? Yeah. Okay.
Okay,
Even
ma'am.
before my colleagues do. Yeah, ma'am.
Ma'am, really, indeed, it was a very good presentation. And you have very clearly explained angle between two straight lines and length of a perpendicular from a point to a line and distance between two parallel lines. And finally, you have explained very clearly the theorem, foot of the perpendicular with examples. So children, hope you have benefited optimally. And madam has explained you in a very clear way, very slowly she has explained. So please revisit the channel, copy down the notes, solve the given problems as madam has given you some task. Try to complete that, practice that, review that. Thank you so much, madam, for the wonderful session you have presented. Thank you.
Thank you, ma'am. Thank you.